Hi, everyone. My name is Pindeus, and today I'd like to talk to you about synthetic data and why I believe it has the potential to enable AI to be the game changer when it comes to addressing some of our society's most pressing environmental challenges. This is Apuí in the state of Amazonas. We've all seen images like that. And we've also all known and heard about the challenges that are rapid deforestation, land degradation, pollution of land and water, the escalating threat of wildfires that seem to be ubiquitous these days, and of course, the rate of rapid urbanization. How do we tackle these massive challenges? Artificial intelligence holds a lot of promise, but it really holds the promise to be able to address and mitigate some of these concerns, some of these challenges, particularly when it comes to Earth observation. We have satellites monitoring Earth 24/7. Applying AI to this data to be able to monitor and really understand how a planet behaves and how to address this is a huge potential. But there's one challenge with AI, and that is the data that it's trained with means that also affects the performance that AI actually has. So the better the data, the better the performance, worse data, worse performance. Now that's something that is solvable, but is really challenging when we think about particularly something like different surfaces on Earth, different places on Earth. How do we actually generate this training data that is high quality, that is high resolution, and that can actually be used to train a model that works for conservation, deforestation, agriculture, many other things, supply chain management? Today, we are seeing quite a few challenges there. A lot of movement with quite a few challenges as well to really make sure that we can leapfrog and help AI accelerate Earth observation. One is data bias, and that's across all industries, but really saying, particularly in Earth observation, saying, well, we need specialized data sets that are high quality and are well distributed, because bias in data and bias in the outcomes of artificial intelligence is truly problematic. We have reliance on natural data. Despite having all the satellites orbiting around Earth, actually getting training data and getting data that, particularly for remote areas, specific use cases, is really difficult and really expensive. It's costly. And then, in order to turn it into training data, to be able to do anything with AI, you need to manually annotate, segment, and it's again costly and has risk of human error. And then lastly, we're seeing more and more high-resolution imagery, which is great, particularly looking at generating insights from that, but with that comes privacy concerns. With images that can look up to 30 centimeters depth from the sky, privacy concerns are a big issue. Now, that is all a matter of how do we prepare data. With Another Earth, we've come together to build a synthetic data engine. And I'll tell you a bit more what that means in a bit. Essentially, the vision here is to build a leading visual synthetic data engine that can generate this training data, that is able to train AI models to then really accelerate Earth observation with it. A bit about who we are. We are a UK and Austria-based business with a strong foothold in Latin America as well, and decades of experience, particularly when it comes to computer vision, digital twins, and synthetic data. So what is synthetic data? It's essentially data that is generated artificially. That is something that doesn't exist in real life. To give you a few examples, synthetic data has been in wide use already for a while, particularly in automotive, autonomous vehicles, in banking, and various areas where you simulate something, create something that doesn't exist, that has all the characteristics from the real thing, and also all the characteristics that you need to train an AI model. And with that, you train an AI model and can then apply it to real data. What it means in satellite imagery is that you create data that has all these characteristics, well labeled, segmented, high quality, high resolution, privacy preserving, all of those things. You train the model and then you can apply it to data that is all out there. So essentially that means that you take input data, any patch of Earth, you segment it. That means you essentially see like where is a river, where is a forest, what crop type, what can go really granular, what soil type. And then you generate synthetic mass, and then you generate the synthetic imagery. And then you can also combine it with 3D generation and rendering to actually have a much more compelling product, in the sense that you have synthetic, new imagery that can also be turned into essentially 3D worlds. And instead of having an image, you then have the image, all the mass, and all the digital elevation, all the 3D pieces as well, which is something that is super exciting, particularly looking at how complex the surface structures of Earth are, right? If we look at Austria, Brazil, UK, everything is incredibly different. But Earth observation, AI in Earth observation is applied, it's going to be applied in all these areas. How do you train the models for that? So essentially, synthetic data for environmental AI essentially means that you can create variable resolutions from low to really high, whatever you need. Obviously, it depends sometimes to be happy with a low resolution imagery, but if you really want to understand something like a crop type or plantation or also deforestation monitoring, you do need to really understand the granularity of the data. Pixel perfect labels, I spoke about the manual job of labeling, which is across AI industries, but in Earth observation particularly difficult because it requires a complex type of actually labeling, preparing training data. Done this essentially automatically with synthetic imagery, accurate information, temporal data, change detection, monitoring how things have behaved over time. How did an area behave over the past, and how is it likely to behave in the future? Is a really interesting one, particularly when looking at conservation efforts, deforestation monitoring, really understand how a piece of land has been behaving and how to monitor that, essentially. So environmental AI, in our definition, is essentially using AI models to create analytics, and those analytics to help monitor what is essentially happening on the planet in terms of sustainability, environmental, like what happens. Agriculture is a big one. How can we enable precision agriculture? How we can conservation efforts? And to do that, providing data that is essentially reduces error rate, has unlimited amounts of these high-resolution data sets, as I explained before, but also creating data where there is none. Because one thing that is really, really critical, particularly being here in Brazil, is that a lot of the data for AI is actually created in the global north by a lot of the supply chain and product and the global south. There's a big disconnect in terms of where the models are, the data is generated and the models are actually applied. Synthetic data can really help there as well. And then, of course, scalable in terms of that you don't need to create a completely new data set all the time manually, but you actually have a synthetic data engine. So what that means, or how the product works, essentially, you pick any place on Earth. Here we're a patch of land in North Rhine-Westphalia in Germany, for instance. And with this patch of Earth, we essentially segment, create a synthetic segmentation mask. What that means is that whatever is relevant, whether it's the crop type, the field, the water, the forest, the infrastructure, the buildings, whatever it may be, is generated synthetically. And from that, synthetic satellite images are generated. What that essentially means is that you can, from the characteristics that you require for whatever your use case may be, you can create unlimited amounts of this data. That is not real, but it's as real because it has all the characteristics and all of those layers of information. And then use this as a training data to train your AI models. And in that sense, creates, in particular, bias removal is a really big one, helps remove bias because the data sets can be as diverse and diversified as you require, particularly when it comes to training AI models, and of course, unlimited data there. So what is also really important, we're talking about generative AI combined with 3D. Using generative AI to create this artificial synthetic data, combining with 3D to then be able to generate all those 3D worlds. And what is particularly exciting here, why I'm so excited about Earth observation AI there, is that it holds so much promise when it comes to the growth rate. Essentially, Earth observation should really be enabled by AI and value-added services. But what we see today is there's all the satellites, and there's more and more satellites out there, and there's this data that is hard to acquire, maybe not hard to acquire, but hard to make usable. And then there's obviously AI that requires all this training data. There's a big disconnect there. So it's really, it's not just an economic thing about accelerating the growth of Earth observation, but it's actually an ethical one as well, because here it's really about environmental monitoring and being able to really help support and put the AI to a use where we can actually help address, hopefully mitigate some of the things that we're seeing that are happening all over the world. And in terms of markets that we're active in, I mentioned a few: forestry, conservation is a really, really big one. Infrastructure and supply chain monitoring as well. So anything that you can actually detect and see from satellite imagery. Agriculture, enabling precision agriculture. That means really understanding types of crop types, predicting how a field or how farmland would and is supposed and intended to behave. For insurance cases, for planning cases, and essentially it's environmental monitoring, right? Helping create better environmental monitoring. one thing that is very exciting for me around the synthetic part is that you can create the amount of detail that you desire, right? So you have this synthetic patch, and you have many, many of those. If you need 100,000, you get 100,000, you need more, you need more. And you can look at the granularity from field to water to infrastructure, and then really go deep down. Soil types, soil behavior, types of fields, grass, water, infrastructure, etc. And because when it comes to Earth observation, any solution has different requirements. Again, it's not just a geographic part, but it's also a type of application, a type of environment. You do really require this flexibility of granularity, of being able to output data that has all of those details and then can be used straight away for training of AI models. Thank you very much. And if you'd like to discuss a bit more about synthetic data and also how it can help and add value to your sustainability goals, happy to have a chat. Thank you very much.